Hi everyone, in this video I want to talk about multiplying and dividing rational expressions. Here are the problems that we'll do. This lesson falls under rational functions, which is an Algebra 2 concept. Technically, we have rational expressions that we are multiplying and dividing. Okay, so when you see a problem like this, you're thinking, man, we have some big fractions that need multiplying and dividing. Well, the first thing I think you should think of in the first problem here is, how could I possibly multiply two fractions and have something cancel out? We want to try to have an answer that's not massive. And so somehow we need an answer that is more simplified. So you can break everything down into factors. So one thing I'm noticing with these terms here is I could take a 6 out and get n plus 9 left over, meaning divide a 6. I could take a 6 out here and have 3n minus 8 left over. And then I could take out, let's see, the greatest common factor between 9 and 24 is 3, but then I can also take out multiple n's. So I have n squared. What's left over? So 3 times 3 is 9, and then we need 1n. This here minus 8. 3 times 8 is 24. Okay, so this trinomial can factor into two binomials, and that would be n, n. And then we need plus 10 plus 9 because 9 and 10 add to 19 and multiply to 90. So right now I'm thinking back to multiplying fractions, and I'm remembering I could do like 1 over 2 times 2 over 3, and those 2's will cancel. They'll cancel out to be 1 over 1, and so this would simplify just down to 1/3. I could also think of this like 1/3 times 2 over 2. So the 2's cancel if they're in different fractions. They can cancel if they're in the same fraction as well. That would just cross out to be 1 over 1 as well. So what's nice is this n plus 9 and n plus 9 can cancel. The 3n minus 8, 3n minus 8 cancel. The 6 and the 6 cancel. And I'm left with n plus 10 over 3n squared. Okay, now on to something harder. These trinomials that I'm noticing in the numerators, those can be kind of tough when you see problems like this, because that number in the front of the x squared, or in this case b squared, it's a pretty big number. So right away I'm thinking, well, why don't I just factor what's down here? I could take a 7 out and do 5v minus 7. And then I could take a 10 out of this and get 7v plus 9. Then I might try, because I know the nature of these problems is that factors will cancel really nicely. So I'm going to try to use some of those with my factorization of the numerators. Okay, so I'm going to try this 5v minus 7 and see what would be left over. So 7v I need to get a 35v squared. And then in order to get negative 7 multiplying by something to get negative 42, that number would have to be plus 6. What I need to make sure is that you end up getting a negative 19v in the middle, so we'll think of it like this 30v and then minus 49v. Hey, that does actually add up to negative 19v, so we're good. And over here, I might try maybe this 7v plus 9. And I need 7v plus 9 times something to end up getting a 49 here, so 7v, and a 54 there, so plus 6. But I do have to verify that I'm going to get 105 in the middle. So we have this. Okay, so that's 42 plus 63, and that is 105. So now I can think about, okay, this is division. Remember that division is the same thing as multiplying by the reciprocal. So I'm going to quickly copy down the first fraction and multiply by 10, 7e plus 9. I need to flip that second fraction. Keep the first, change the sign, and flip the fraction after the division symbol. So we have 7v plus 9, 7v plus 6. Okay, the fun part. Cancel, 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 and the answer is just 10 over 7. Now, to make sure we don't take ourselves too seriously, let's think about the fun question. What is your favorite color now, and what was it 10 years ago? Let's go on to a little bit of practice. Try these two. We have division, then multiplication. Feel free to pause the video before I show the answers. There they are. And before I leave you, I always like to give you a quote for good measure. I think about the ripple effect a lot when I work in a school setting. So I like this quote a lot. Just as ripples spread out when a single pebble is dropped into the water, the actions of individuals can have a far-reaching effect. That's from the Dalai Lama. I hope this video benefited you, either with a math course or prepping for a standardized test. And now that you've had some time to ponder that fun question, I'd love to see your answers in the comment section. Also, if you could please subscribe, I would really appreciate it. If you would like to keep up with the videos in the future, have a great day.